Good evening to all the participants. I welcome you all on the fifth day of this faculty development program, which is sponsored by AICTE ATAL on risk to resilience, innovative resilience strategies for mitigating climate change. And we have with us Dr. Sonam Paliya today. She is working as an Alexander von Humboldt postdoctoral fellow at the RWTH Aachen University, Germany. She has more than 10 years of experience working in the broad field of biological and environmental science. She has completed her master's in biotechnology from Barkatullah University, Bhopal. She completed her PhD from the Academy of Scientific and Innovative Research, working at CSIR NEERI, Nagpur, under the supervision of Dr. Sunil Kumar, who is Senior Principal Scientist and Head, Waste Reprocessing Division at CSIR NEERI, and Dr. M. Suresh Kumar, Chief Scientist and Head, Environmental Impact and Sustainability Division. Her primary area of expertise is in bioremediation of persistent organic pollutants and emerging contaminants, also biovalorization of waste, covering wide range of environmental topics, including environmental impact assessment, life cycle assessment, and wastewater treatment. Dr. Paliya had cleared national level examinations, including UGC NET, ICAR NET. She was also awarded fellowships under UGC NET JRF and RGNF, Government of India, to pursue her doctoral studies. She was awarded the Best Young Researcher Award 2020, late Shri P.S. Dutt Memorial Award 2020 for Research Scholars by CSI at NEERI, Nagpur, and MP Young Scientist Training Fellowship by Madhya Pradesh Council of Science and Technology, India, for 2017 and 2023. She grabbed the National Postdoctoral Fellowship by DST Serve in the year 2022. She has published her work in peer reviewed journals, which are of high impact factors. She has also 19 research and review articles, 10 book chapters, and a prolific author and editor. Dr. Paliya has made significant contributions to research and academia. Her book series, Environmental Resilience and Solid Waste Management, approved by Trailer and Francis Group, CRC Press, is a testament to her commitment to disseminating knowledge. In addition to this series, she is actively involved in editing book titled Bioenergy, a transformative pathway for climate resilience and sustainable progress, which is approved by the Royal Society of Chemistry and has three more edited books approved by Springer Nature Group, Taylor and Francis and Bentham Science publishers, which are in the process of publication. Besides her contributions to multiple books that delve into pressing environmental issues such as waste management, wastewater sludge, climate resilience, and bioenergy solutions, Dr. Paliya has made significant contributions to the field of environmental science and waste management, both at the national and international levels. Her extensive list of conferences, papers, posters, and invited talks reflects a dedication to promoting sustainable waste management practices and environmental awareness. With 552 citations at the Google Scholar, H index of 12, and I10 index of 12, I welcome Dr. Paliya to our faculty development program, and we are glad that she could share her experience and insights with us. Thank you, ma'am. I request you to take over.
Sure. So thank you so much, Dr. Jagmani, for this brief introduction and inviting me for this talk on this AICTE ATAL sponsored 1 week program, faculty development program. So thank you so much for the invitation and for this opportunity. So shall I start, right?
Yes, ma'am.
So, okay, I'm sharing my presentation. You'll have to enable me to present or share my screen.
Ma'am, see if it is sharing right now.
Yes, now I can see.
Ma'am, your screen is visible to us now.
Okay, so I have shared my screen and I hope this screen is visible to you all, right?
Yes, ma'am, it's clear.
Yeah, and hope it is moving now.
Yes, ma'am.
Yeah, because I don't want to interrupt in between. So yeah, thank you so much for handing over me this session. So a very good evening to all the fellow colleagues and participants present here. I'm Dr. Sonam Paliya, and currently I'm working as a Ali Center for Humboldt Fellow at the Institute for Organic Geochemistry and Geosystems at the RWTH Aachen University, Germany. And thank you so much for this invitation at the AICTE ATAL sponsored 1 week online faculty development program on risk to resilience, innovative resilient strategies for mitigating climate change. And today I'll be sharing insight on contaminants of emerging concern and sustainable remediation strategy. This is the topic of my today's talk. So starting with the pollutants, like we are surrounded with so many pollutants or chemicals which we are using in our daily life, like persistent organic pollutants, emerging contaminants. These are the chemicals which we are using in our daily life products, such as personal care products, car washing substances, shampoos, right? Electric and electronic equipments, and this TVs, casings, plastic, plasticizers, polyurethane foams, paints, adhesive, glues, everywhere. Anything which we are using in our daily life, it's containing some kind of chemicals. Some of them are hazardous, some of them are non-hazardous chemicals. So the chemicals which are hazardous in nature, so people are working, or scientists or researchers are working on those chemicals, like, oh, okay, this kind of toxicity, this kind of substance is generating or showing this kind of toxicity. So there are some kind of regulatory authorities which are regulating these chemicals or pollutants and considering them as a hazardous chemicals and banning them, right? So these are some estimates of projected growth in world chemical sales, which is showing in 2017, 3.47 trillion of chemical sales was there, which was like projected to be increased by 6.6 trillion euros by 2030. And global chemical industry exceeded USD 5 trillion 2017, and it is projected to grow up to double by 2030. So this is the world chemical demand and sales and export, import and use of chemicals. And these are some other attributes showing in 2016, we could save 1.6 million lives and around 45 million disabilities by sound and proper management of waste containing harmful chemical or hazardous chemicals, which includes chronic kidney diseases and poisoning, self-harm, cancer, chronic obstructive pulmonary diseases, cardiovascular diseases, etc. So these are the diseases which took 1.6 million lives due to the improper management of waste containing hazardous chemical substances. So where does the India stands in chemical industry? So India ranks 6th in the world in the production of chemicals and 4th in the production of agrochemicals, which, like in India, we can see a hell lot of chemicals or pesticides we are using in the farms and agriculture. And even recently I heard that Madhya Pradesh is one of the most this is the state which is showing more this thing, heavy metals in the fruits and vegetables. So India accounts for 16% of dye stuff and dye intermediaries and is a global supplier of dyes. Textile industry is also a bigger industry in India, and excluding pharmaceutical products, the chemical industry in India ranks 14th in the global export, employs more than 2 million people, and its value is expected to rise $304 billion by 2025. So India and in the world, we are using too many chemicals in a hazardous and behemoth quantity in different kind of substances. So there are a number of the sustainable development goals which are talking about the chemicals and hazardous chemicals and waste containing chemicals, like zero hunger, clean water and sanitation, responsible consumption and production, no poverty, life below water, and this peace, justice and strong institution, and some other goals including health, water, cities, and human settlements, oceans, and sustainable consumption and production, and so on. So there are a number of sustainable development goals which are also pointing out towards the sound and proper management of chemical containing waste. So we are generating a number of chemicals for different kind of things, right? For different kind of products which we are using. So there are three different organization which are taking care of these chemicals, like what kind of chemical should be produced, should be exported, imported, and used, and what should be the criteria. So first convention is Basel Convention, which takes care about the control of transboundary movement of hazardous waste and their disposal. This convention came into existence on 10th September 1998, and now till now 190 parties has been like signed this Basel Convention. And the objective of this convention is to protect human health and the environment against the adverse effect of hazardous waste. And the basic scope of this convention is the hazardous waste and hazardous chemicals. So this is the Basel Convention, and the second convention, which is Rotterdam Convention. So this convention takes care on the prior informed consent procedure for certain hazardous chemical and pesticides in the international trades. So this convention takes care of the introduction of the new chemicals in the market. It regulates on the like introduction of new chemicals, like what chemicals can be introduced into the market or not. So this particular convention came into existence on 24th February 2004, and till now 165 countries has been signed this Rotterdam Convention. And the objective of this convention is to promote shared responsibility and cooperative efforts among parties in the international trade of certain hazardous chemicals. So the first convention is related to the waste management containing different hazardous chemicals, and the second convention, which is Rotterdam Convention, takes care of the chemicals which can be introduced into the market or not. And the third convention is the Stockholm Convention, which takes care of the persistent organic pollutants. So we will later on talk about the persistent organic pollutants and emerging contaminants, which is the like core of this talk. So this Stockholm Convention came into existence on 17th May 2004, and till now 185 countries has signed this treaty as of February 2022. And the objective of this particular convention is to protect human health and the environment from persistent organic pollutants. So the basic scope of this particular convention is the listing of chemicals as a persistent organic pollutants. So what are the persistent organic pollutants and emerging contaminants? So basically, so many chemicals are being introduced into the market for different purposes, but some of them are lethal or hazardous for the human health, and some are having some alternatives. So government or regulatory authorities can ban them from their import, export, production, and use. So they are listing those chemicals as a persistent organic pollutants in the Annexure A of Stockholm Convention, and some chemicals which can be registered into the Stockholm Convention, or which are like not regulated yet, but they are emerging as a emerging contaminant due to their several toxicological effects. So here, first of all, emerging contaminants. So chemicals which are naturally occurring or synthetic that have become recognized as occurring in the environment and may potentially pose a risk to human health or the environment, they can be considered as emerging contaminants. And analytical method improvements or use of GC, HRGCMS has enable us to even identify or detect the very smaller PPG, PPB, PPM level amount of these chemicals. So a very little is known about the health impacts of these chemicals, but they are widespread and persistent in the environment and tend to bioaccumulate. Effects of a mixture of these chemicals are still unknown, but they have very hazardous impact on the human and biota. Again, over 30 million organic and inorganic chemicals have been registered as emerging contaminants, and more than 5 million in the last 2 years alone. And 13 million are the commercially available emerging contaminants which we are using in our daily life, like such as pharmaceutical products or self-care products. So the category of these emerging contaminants are pharmaceuticals and personal care products, which we can call PPCP, pesticides like linden or chlorodiken or DDT. These are the pesticides. Endocrine disrupting chemicals, such as chemicals which can mimic the endocrine system of the human body. Some chemicals are having the similar structure with the thyroid hormone system, like T3 and T4 hormones. So they can mimic the endocrine system of this hormone, and they can alter the growth, or they can generate a abnormal behavior in the human body. And some are flame retardants, which we are using in the electric and electronic equipment for the flame retardancy. And some nanoparticles are also registered or listed as emerging contaminants. And prions, this is a new word, which is infectious proteins, and virions, which I haven't mentioned or written here, but virions, which are the virus particles, they are also considered as a emerging contaminants. So these are the category of emerging contaminants, and n number of compounds are like becoming emerging contaminants now these days. Previously, we were having one substance, parabene, right? Paraben, which were included in several this skincare products. But now these days we can see one tagline is there on the bottles, like paraben free, because this paraben has been listed as a emerging contaminant or persistent organic pollutant by the Stockholm Convention. So it has been banned, and now people are not using it in those particular formulations. So these were the emerging contaminants. I am having towards the persistent organic pollutants. So basically, persistent organic pollutants are the synthetic organic chemicals, mostly the chemicals which are organic in nature and halogenated organics. And they can persist in the environment for decades, and they resist for the degradation as well. They are lipophilic in nature, which means they are fat soluble, not this water soluble. They are lipophilic, excluding this PFAS, which is water soluble or hydrophilic, and they can accumulate into the food chain because they are lipophilic. They can cross the this plasma membrane of the cell, and they can accumulate into this human cell or any other biotic cell. So they are accumulate, they have the capacity to accumulate into the food chain. They have long range atmospheric transport and leads to global pollution. Even their traces have been reported into the Arctic and Antarctic regions where there is no point source. So we are generating the chemical. We cannot say like we are not generating the chemicals in the India. We are not producing this kind of chemicals. So we don't have this kind of pollution. No. Due to this transboundary movement, we can also have the pollution of the substance which is being produced in the Europe or in Australia or in the US, right? So this is the problem with these chemicals. So high levels in the fish and marine mammals, and we can see that in the developing countries like Asian countries, people consume this marine substances like fishes and crabs and this only. And high level of these substances have been reported in the marine mammals. And acute toxicity is well characterized about these persistent organic pollutants, but effect of low level of chronic exposure is still unrevealed. In our one of the study, we found that this municipal waste dumping sites of the India having a huge amount of this persistent organic pollutants, which we analyzed, selected the persistent organic pollutants, polybrominated diphenyl ethers. There we found the level of these compounds is like less than was having less than one of hazard quotient, but their chronic exposure can lead towards the hazardous this thing impacts on the workers who are working in the vicinity of those dumping sites and people who are living in the vicinity of those dumping sites. So this is the scenario with these persistent organic pollutants. Now, what are the sources of these persistent organic pollutants or these emerging contaminants? So, emission from industrial processes such as waste incineration, cement, steel, paper, and pulp industries, like substances we are getting from these industries are dioxin and furans, PCBs, PCNs, PAHs, which is a very concerning chemical, PHs, which people are like now exploring in the marine environment as well due to this oil spillage and all these things. And pentachlorophenol, pentachlorobenzene, hexachlorobenzene, etc. and emissions leaching from waste disposal. So we are directly or indirectly, due to this poor waste segregation system, we are dumping all the waste containing all the substances on the landfill. So from there as well, we are getting this PBDs, UV filters, HBCDs, PCBs, PCNs, P4s, PFOA, and its salts, and release from products in use like plastics and textiles. These like persistent organic pollutants and emerging contaminants, they can directly incorporate into the material, or they can be coated on the surface of the material. So many flame retardants like PBDs and this HBCDs are being used in plastic and textile materials, right, as a flame retardant. And some of them are being used as a plasticizer and stabilizer. So they can leach out from these kind of products, or historical use like chlorinated pesticide DDT. DDT was used in a behemoth quantity for the malaria and this thing mosquito, as a mosquito repellent as well. Government used this DDT. Hexachlorobenzene, endosulfan, endrine, delderine, eldrine, toxaphene, these are the chemicals which were used, but their existence is also there in the waste which we are having on the open dumps. So this is the problem with the POPs, and these are the sources of POPs. And persistent organic pollutants have been reported by the several organizations like US EPA, Environmental Protection Agency, which is so they have been reported, and there are a lot of number of these reports on the hazardous impacts on of persistent organic pollutants. So this is the report of EPA, which is showing persistent organic pollutants a global issue, a global response. This was the report of EPA. So what are the category of POPs? How we can understand what are the POPs? So there are three different category of persistent organic pollutants, which is POPs, which is a very fancy name. So one is pesticides. So in pesticides, we can consider eldrin, chloridin, toxaphene, DDT, HC, endrin, and dendrin, heptachlor, HCB, Mirex, and industrial products such as PCB and PBDs. These two, PCB and PBDs, are flame retardant. Others are the pesticides, and some other are the unwanted byproducts. When we openly dump a waste containing like plastic, so dioxin and furans, which is like very emerging contaminant now these days, so they get generated during the open burning of this particular waste. So PCDD, PCDF, PHs are the substance which are the unwanted byproducts of these POPs category. So initially, as I have mentioned earlier, that Stockholm Convention is the treaty who is taking care of these chemicals which are hazardous in nature. So that is came into existence in 2004. So initially they listed 12 different chemicals which were very hazardous in nature. So among them, 8 were the chemicals which were in the category of pesticides containing eldrin, chloridin, DDT, delrin, endrin, heptachlor, Mirex, and toxaphene. And 2 industrial chemicals were there, HCH and PCB. Now PCB has been banned, and PBDs is the alternate of this PCB. But Stockholm Convention has listed this PBD as well as a this persistent organic pollutant. So we are just looking for the alternative of PBD for the flame retardancy, because PBD is the most prevalent this thing flame retardant. And 2 byproducts were there, chlorinated dioxin and chlorinated furans. Now, Stockholm Convention listed 16 new POPs, or introduced 16 new POPs in the list, which is alpha hexachlorocyclohexene and beta hexachlorocyclohexene, chlorododecane, hexabromobiphenyl, and tetrabromodiphenyl ether, pentabromodiphenyl ether, decabromodiphenyl ether. These are the congeners of these PBDs, and short chain chlorinated paraffins, as I mentioned, like parabene, paraffin, and hexabromocyclododecane, hexabromodiphenyl ether, and heptabromodiphenyl ether, hexachlorobutadiene, lindane, and pentachlorobenzene. So these are the chemicals which have been listed as a new POPs in the Stockholm Convention. So what kind of chemical or physicochemical properties these persistent organic pollutants or emerging contaminants have. So they are semi-volatile compounds which have the boiling point from 240 to 400 degrees centigrades, and hydrophobic and non-polar they are in nature. Like exception is PFAS, as I mentioned earlier. Less soluble in water and more soluble in lipid, enrich in organic rich soil, sediments, foliage, and similar matrices, distribute partition between the air and soil sediment. So as they have less solubility in the water, they have more affinity towards the particulate phase. So they don't get solubilized into the water, so they get just accumulated on the particulate phase. So in water bodies as well, the problem is that they just this stick with the sludge particles, and they just hide beneath this water surfaces, right? So transported to long distances via air, water, and migratory species, deposition, volatilization, and continuous process influenced by the climate. So what are the climate process which are like increasing the transboundary movement of these chemicals, which I will talk in my next slides. So what is the screening criteria for these chemicals in the International Chemical Convention? How they identify which chemical should be listed in the Stockholm Convention or Rotterdam Convention or Basel Convention. So according to UNECE report, the particle or the chemical which are like having their half-life time more than 2 days in the air, more than 60 days in the water, and more than 180 days in the soil and sediment, and have ecotoxicity and human toxicity, they can consider as the persistent organic pollutants or emerging contaminants. According to report of US EPA, the half-life time of the substance, if more than or greater than 2 days, and 60 or 180 days in the water, and 60 180 days in the sediment. And accordingly, this Stockholm Convention has also followed the same criteria and evidence of adverse health impacts on the human health and the environment. So those like the chemicals which are having half lifetime more than 60 days in the water and more than 180 days in the soil and sediment can be considered as persistent organic pollutants. We can understand from the name itself, they are very much persistent in the environment. As they can persist in the environment, they can cause the harm for human and biota as well, right? And this is the criteria for persistent organic pollutants in the air. Like as I mentioned, that half-life time should be more than 2 days. Prior to 1990, only half-life time in water was considered to define the persistence, according to this Great Lakes Water Quality Monitoring Program. But now, in air persistence is also a criteria for the selection of persistent organic pollutants. So how they select or how they characterize a substance or chemical as a persistent organic pollutant? So first of all, researchers like you and me research thoroughly on one chemical, like what is the toxicity related to this compound. Like some people are working on PHs, I'm working on PBD, some are working on flame retardant. So we submit papers, and based on those papers, as because we can understand where our research is very much important here. So considering those papers or articles, this convention prepare a new proposal by the party, and they screen according to criteria which I have mentioned earlier, develop a risk profile, like what are the toxicity, can this risk things are manageable or not, risk management evaluation, whether we can manage risk associated with this compound or not. If it is manageable, so we can consider them in the annexure B or C. If this is not manageable, so then Stockholm Convention lists those compounds in the annexure A for complete ban to on import, export, and the use of those compounds. So this is the criteria for the Stockholm Convention inclusion list of new POPs. Now, how we are getting exposed with these compounds? So we are getting exposed with this compound through dermal contact, inhalation, ingation. We are like inhaling in the environment. So we through the inhalation as well, through the particulate matter. As we can see, I visited Delhi in the October or in the mid-November. So that time, like the AQI index of that Delhi area was more than 1500, which was equal to smoke like 50 this cigarette butts in a day, so which is very hazardous. So we are getting exposed through air or through inhalation or through food intake. If we are like in like uptaking any kind of food like vegetables or marine environment things, so we are getting exposed through the food items as well, dermal uptake as well. We are in the environment and dust particles are there, so we can get exposed through dermal contact as well. And for especially ladies, we are using so many chemicals on the face and body. So and now these days, this vitiligo is very prominent in the ladies in the India, we can see, right? So these are also like byproducts of these kind of hazardous chemicals. So and these are the pathway by which we can get this exposed with the POPs and emerging contaminants. And the most specific or the concern is about these chemicals is that their concentration has been reported more in the indoor environment than the outdoor ones, because we are using so many hell lot of substances like things like TV, mobile phones, electronic equipment, so many wiring, sofa set, couches, and polyurethane form substances like matting. So all these substances having some kind of emerging contaminants and persistent organic pollutants. So our indoor environment is more prone for the exposure than the outdoor ones. And the most concern about these substances that their concentration have been reported more in the infant and children than the adults, because they have less body weight, they have hand to mouth activity, they crawl on the surface, they use different which are like made up of plastic or polyurethane form. So through this hand to mouth activity as well, they are getting exposed. So these are the concerns related to the exposure of POPs. They have biomagnification power. So here we can see that water is a treaty in which like they are showing 0.0000003 ppm, and then this water is being consumed by the zooplankton, in which we can see like 0.04 ppm is being transferred, and then small fishes are eating these zooplanktons, and zero point 0.5 ppm is being transferred in these small fish. So here the volume is being reduced and the amount is being increased of these emerging contaminants and POPs. So as we can see in the higher in the organisms which are on the higher side, they have more amount of these POPs or emerging contaminants in their body, and we are consuming these fishes and crabs and all those things, so we are getting exposed. Now, this is another problem associated with the persistent organic pollutant or any kind of chemical which are being produced like in the Europe or in India or in any other this Asian countries, but we can get exposed through these chemicals through the global distillation effect. At the like I can say that altitudinal effect. So less volatile POPs, like more chlorinated POPs, which are like having more this thing mass, so they can deposit in on the high altitudes and near the sources. And the substance which are highly volatile or less chlorinated or having the less biomass or mass, they are found at lower concentration at the higher altitudes. So through this global this distillation effect, the concentration of these flame retardants and other persistent organic pollutants have been reported into the Arctic and Antarctic regions and the oceans as well. However, their concentration is not that much, but yes, their traces have been reported in the Arctic and Antarctic regions as well. And another problem which is associated with the persistent organic pollutants or emerging contaminants is that this e-waste movement from developed countries to the developing countries. As the cost of this e-waste recycling or dismantling is less in the developing countries like Asia, this India, Pakistan, and China. So all the waste from European countries and US, we are exporting this waste and we are dismantling for the recycling of this precious metals and other substance from this e-waste. So e-waste is very much hazardous, which contains a number of persistent organic pollutants and emerging contaminants, including this plasticizer or flame retardants, etc., which contains PCB and PBDs. So what are the effects? So as I mentioned earlier, that like endocrine system, so they can mimic the endocrine system, they can mimic several hormonal system in our body, and they can disrupt, even they can disrupt the neurotransmission system of our body, to send the signal from one body part to the brain, or from one body part to the another body part. We have one mechanism which is neurotransmission in our body. So these chemical can mimic the structure of those neurotransmitters, which are protein in nature. So they just mimic the structure of those neurotransmitter, and they give a false signaling to the neurons, and generates like this dysfunctional of immune system, development and reproductive system, fertility problem, disease susceptibility, etc. So these are the effects of POPs on wildlife and humans. Now, why is global action is necessary? So POPs has the capacity to travel long distance from source where it is not produced and harm human health and the environment. One quote is there from the Dr. Klaus. According to Dr. Klaus, no government acting alone can adequately protect its citizens or its environment from the threat of POPs. Because of the distillation effect, grasshopper effect, transboundary movement, e-waste movement, we cannot say like we are not producing it, so we are safe. So every government will have to take care of these chemicals. This is why these Stockholm Convention, Rotterdam Convention, and Basel Convention like came into existence, and different countries signed those treaties for the prevention of these persistent organic pollutants and other hazardous waste management. Now, emerging source of atmospheric toxicants. So, e-waste recycling is the most prominent source of this atmospheric toxicants. So, which involves melting and acid leaching of e-waste to recover precious metals. But PCBs and other semi-volatile organic substance also can be leached out from these e-waste during the recycling. And open burning of municipal solid waste is also a very big problem. So it is not about the burning of municipal solid waste only. Even this biomedical waste, which also contains too many plastic substances, this is also a problem, like which can generate this persistent organic pollutants and other chemicals. And informal e-waste recycling in Indian cities. So India has been suggested to be second to China in processing e-waste, with 70% believed imported from abroad. So we are recycling 70% of the e-waste which is being imported from the developed countries. And 25,000 workers are involved, which are like considered to be in the informal this recycling system, and among them 95% are dealt by the informal recyclers. So this is the scenario. You can see without any precautionary measures they are recycling on different things which can have the batteries and acids and several hazardous substances. And again, the plastic debris or plastic is also a very big problem or very big challenge for all the countries, especially in India, because plastic is a cocktail of chemical contaminants, including PBDs, phthalates, methyl mercury, DDT, PHS, styrene, PCBs, BPA, which in plastic, like some substances are fillers like calcium carbonate, talc, and silica, mica, glass beads, and alumina, and stabilizer, lead cadmium compounds, and plasticizer, phthalates or phthalic acid esters are being used, flame retardants are being used, biocides and antioxidants, plastic waste generated toxic gases such as dioxin and furans, and PHs, which are the byproducts of these persistent organic pollutants. So plastic is also a major source of this kind of substance into the environment. Now, I will discuss some findings of the global monitoring program. We have discussed like what are the persistent organic pollutants, what are the emerging contaminants, how we are getting exposed, and what are the sources. Now, what is the concentration, which is being reported or which have been reported into like globally in different countries of different substances. So for the estimation of POPs, like different analytical methods have been developed. Even during my doctoral studies, I have developed analytical method for the detection of polybrominated diphenyl ether, which was the baseline study in India, because previously there was no data related to these polybrominated diphenyl ethers in India. So being associated with the CSIR, which is a regional center for Stockholm Convention, I generated this baseline data and this analytical procedure. So first of all, we collect the samples. In that can be a biological sample or any environmental sample. We separate these chemicals or extract these chemicals from that particular sample through liquid extraction, solid extraction, solid extraction, and we purify those substances, because soil and sediment and this water is like are very complex medias. So we cannot segregate or extract substances or chemicals of like which we desired very easily. So we'll have to adopt a protocol for the extraction process, and it takes like SOX therm or any microwave digester or some other equipments for the extraction. And after extraction and purification, we can go for the quantification of these chemicals using GCMS, GCMSMS, GCHRMS, LCMS now these days. So these are the equipments which can be used for the detection of very lower amount of these substances, because their concentration are in the nanogram or picogram in the environment. They are not present in the ppm or ppb level in the environment, but there this much concentration in the nanogram or picogram is very much hazardous. It's the acute exposure and chronic exposure as well. So these are the available techniques for the estimation. So, according to this global monitoring program, there was a significant decrease in the old POPs, including PCB and DDT and PCDD, due to the imposing ban on these products. But their these stockpiles are like present in the existing waste stream as well. And the increasing order of this sharp increase in this new pops like BFRs and SCCP has been recorded. Now, these are the toxic equivalent level of dioxin-like compounds analyzed in the period of 2000 to 2010 for specific countries. So here we can see that the highest amount has been recorded in India, some parts of Europe, nearby the Italy and Russia. These are the compounds which are dioxin-like compounds. And this is the human milk monitoring studies or program. Here we can see the highest amount has been reported in Spain, Ukraine. These are the countries which are having the highest amount of HCB, which is a persistent organic pollutant. And again, this is the human milk monitoring study. As why I am showing this data of human milk monitoring study, because there are like ways where we can collect or extract these chemicals, because they are lipophilic. So there are chances that we can get these chemicals in the human milk, hair, even feces are also like estimated uh, for the monitoring, and serum. But the major source of this particular persistent organic pollutants or emerging contaminants can be human milk, because of the lipid substances in the that particular media. So this about the deltrin. So deltrin has been reported highest in the Australia and New Zealand areas. And this is the sum of six indicator PCBs, which is showing the highest concentration has been reported in Spain and Italy countries. This is the data from 2000 to 2012. So now, what is the work related to these persistent organic pollutants, which is going on in our research group? Now I will talk about that a bit. So here we are working on polybrominated diphenyl ethers, which is a category of flame retardants or some other selected persistent organic pollutants such as PFAS and this microplastics as well. So here we chose these persistent organic pollutants because if I'll talk about the Indian scenario, so in India, we have listed only 12 old POPs yet, and very recently in 2021, 7 new POPs have been introduced into the National Implementation Plan for the imposing ban in the India. But this decabrominated diphenyl ether and other substances like hexabromociclorhodicane, which is HBCD, hexabromodiphenyl ether, and heptabromodiphenyl ether, tetrabromodiphenyl ether, are still excluded from this list of national implementation plan because we don't have any baseline data related to these substances. So first of all, the researchers who are working in the India will have to search the or create the baseline data related to these substances. In this research work, we are focusing on penta, octa, and deca-BD because they have several toxicological effects, and they are being used in behemoth quantity in different kind of substances, including electric and electronic equipment, polyurethane foam, adhesive glues, paints, etc. So these are the live example of use of these polybrominated diphenyl ethers in different product. Like first one is the example of use of these PBDs in paint substances. Second one is the example in the plastic pipes. And in the third one, concrete material is being tested for the flame retardancy. So
It's
these are
changing,
the
ma'am, now.
yeah. So these are the commercial name and production of PBD mixtures. So commercially, Deca BDs is available in the market with the name of Bromcal 75 and Bromcal 82, ODE, D83, D83R. So these are the name of different substances like Deca, Octa, and Penta BD. So we focused on these polybrominated diphenyl ethers only in our study. So these are the trade names of these chemicals in the market. So they are being used in the EVA material like Decabetes is being used in the amount like 0.16 mg per kg of this EVA material, and PPE material it is being used in quantity of 0.5 mg per kg, and in PCABs material. Like this material you can see in this material it is being used in the quantity of 0.65 mg per kg, which is very much high for the toxicity levels. So these are other studies which are showing use of this DECA-BD, which is excluded from the imposing ban from import, export, and use of this DECA-BD as a flame retardant in different substances. So here, this DECA-BD has been reported in hard plastic toys, butter wrappers, and electrical and electronic equipments, and TV casings, and so on. So these are some reports showing the concern related to these compounds like electronic waste releases shocking levels of PBDs, livestock feed accurately predicts toxic chemicals in food, mother's milk, health risk of PBDs. So these are the reports which are showing concern of this PBDs. So here in this study, the first objective of ours is to identify the concentration of these polybrominated diphenyl ethers in the Indian environment. Currently, I am associated with the RWTH Aachen University, and here I am working on a project where I am bridging gap between the Indian and European environment. So currently, I am working on the samples of European environment, and I found that phthalates and PFAS are the emerging contaminants which are present in the European environment. So here for this PBD analysis, we collected sample from the municipal waste dumping sites. So here we chose dumping sites from the more populous cities and less populous cities, and we collected soil samples in the vicinity of these dumping sites, and these are some glimpses of the sample collection. And we analyzed those samples for the physicochemical analysis and this PBD concentration. And in the second phase of studies, we collected samples from the wastewater treatment plant. This is the a wastewater treatment plant situated in the Nagpur city, which has the capacity of 130 MLD. So here we collected samples from all the processes of the treatment, so that we can identify whether our existing treatment process is able to degrade these compounds or not. So interestingly, here we found that 90% of this PBDs was getting deposited onto the this dewatered sludge, and remaining amount was getting discharged like through the effluent. So this dewatered sludge is directly being dumped on the landfills. It is not being treated by the this government bodies or whosoever is operating this plant. So it is directly being dumped on the landfill, from where in the particulate phase it can harm the people who are in the vicinity. They can deposit into the water body. So these are the results related to this particular study. So we also tried to isolate and identify the bacteria. Like in the developing countries, we have activated sludge process for the wastewater or municipal sewage treatment. So, is there any possibility that we can incorporate some kind of culture or some bacteria which can degrade, some selected persistent organic pollutants or persistent organic pollutants having like halogenated things on the benzene ring? So, we isolated and identified the bacteria. So, here we, like after determination of the contaminated site, like, okay, this municipal waste dumping site is contaminated with the this particular PBD. So we collected sample from that particular contaminated site, and we just inoculated our specific media which we prepared for the this isolation of these bacteria. So we used BD209 or DecaBD as a sole carbon source here, and we after 3 months of incubation we found this mixed culture. Among this mixed culture, the bacteria which were like more in the quantity and which were more having the more survival rate, we like isolated or purify those bacterias. And we also check the different effects of different this in inoculum size and this co-substrate concentration, substrate concentration, pH, temperature on these bacteria, like which is the suitable or optimum condition for the for the growth and degradation of the BD by these bacteria. So here we found that these four bacteria which we were isolated were novel in nature. So we named them as a strain BD-S1, strain BD-S2, strain BD-S3. They all were having the similarity with the this Bacillus family. So one bacteria was like Lysine capsicum, Lysine macroides, and other bacteria Bacillus subtilis, and this is Lysine macroides. So we named as strain BDS3 and BDS4, and we submitted the database sequences in the NCBI database system, and we are in the process of filing patent for all these bacteria. We also identified the possible degradation pathway for the bioremediation of this particular brominated compound. So here, this is the pathway by Bacillus stichilensis. So here we can see that Deca BDs is being converted into the BD 153, 154, BD 199, 47. Now, what are these like VD 154, 153, 199? So, there are like 10 different categories of this particular polybrominated diphenyl ethers. As we can understand from name itself, it is polybrominated diphenyl ether. So, two phenyl rings are associated with the ether bond, and there are halogen atoms or brominated atoms attached with these rings from the number 1 to 10. So if the number is 1, it is monobrominated diphenyl ether. If the number is 10, so it is decabrominated diphenyl ether. And if the number is 1, so on the basis of the attachment of this positioning of this brominated atom as well, there are 209 possible congeners of these compounds. So it is very tricky to handle these kind of substances like PCB and PBDs. So this DecaBD is being converted into the BD47, and then one more less toxic compound, and then S2 and CO2. So fortunately, we were not like having any more toxic substance after the incubation period. And this is the pathway by other three bacterias, which is Lysine Bacillus capsicum, strain BDS2, S4, and BDS3. So here as well, we found a complete degradation of this DecaBD by all the three bacterias. So, as a novelty of this research work, this was the PBD contamination study in municipal waste dumping sites, which was determined first time in this study, and occurrence rate mass loading of PBDs in this Indian sewage treatment plants reported first time in the study. We isolated 4 novel indigenous bacteria and screened them and identified them. We also predicted possible BD209 degradation pathways by the Bacillus stichilensis strain BDS1, Lysine capsicum, strain BDS2, Bacillus subtilis, strain BDS3, and Lysine macroides, strain BDS4 were predicted first time in the study. So this was the summary of our research work. Here, approximately 60 to 65% of degradation we achieved in this particular research work. So currently I'm working on a project which is development of in situ remediation process for the removal of brominated flame retardants from wastewater. So here I'm working on the entire this brominated flame retardant categories, because 40% of this flame retardant market is occupied by the this brominated flame retardant, which contains polybrominated diphenyl ethers, hexabromocyclorhodicane, and tetrabromobisphenol A, polybrominated biphenyl. So these are the categories of brominated flame retardants, because we cannot consider too many of persistent organic pollutants or pollutants in like in particular one project or study. So we are focusing on these chemicals. So here I will skip this slide. So here we are working on these compounds, and apart from these compounds, we are also working on PFAS and this plastic waste as well, and microplastics. So with this, I'm ending my this lecture of this on this persistent organic pollutants and emerging contaminants. So these are my publications. Like I have 19 published articles, as like Dr. Jagmani already told, and currently I am working as an editor in the Frontiers in Nanotechnology as well, and I am official reviewer for the Journal of Environmental Management, Chemosphere, Environmental Geochemistry and Health, Exposure and Health, International Journal of Environmental Science, and etc. And these are our current ventures. If you guys are interested to submit a chapter or to submit a book proposal in our book series, so you are free to submit. You can contact us. So with this, thank you so much.
So I would like to thank you, ma'am,
Thank you.
for enlightening us over this wonderful topic of persistent organic pollutants. And I'm really thankful that you would take time out of your busy schedule, although
Mhm.
you are over an international conference over there. Still, you managed time for us today.
Thank you so
I'd
much.
like to open the session if any of the participants would like to interact with Madam.
Actually, I took only 1 hour because I was having one more commitment after this lecture. So yeah, and we can interact during this time. So I just finished.
So, any of the participants, if you would like to have an interactive session with ma'am, you can get in touch with us, or you can also email to her directly regarding any of the support you would like to have.
It's a very emerging topic. So I am very much interested or open to discussion on this particular topic. If anybody wants to ask anything, yeah, please.
Thank you so much, ma'am.
Any students of IPS Academy? If you want to ask anything, you can ask.
Yeah, good evening, madam. I am Dr. Vinishwi Nair from Kerala.
Yes, sir. Yeah, good evening. Very good evening.
So you are talking about detail about the POP, and in your opinion, is bioremediation is the only method for the removal of this POP?
In my opinion, bioremediation is not only method for the remediation of this compound. I am working on the bioremediation. There are some other strategies like advanced oxidation process, Fenton process, or electrocoagulation, or some other processes are there like adsorption. But all the processes like which are existing, like physical or chemical or biological process, they are like not that much techno-economically sound. So I am working on the bioremediation because I am having expertise in this particular domain. And the bioremediation is like by bioremediation, we are getting like good results for the degradation of persistent organic pollutants. But we can, yes, definitely use the nanoparticles and catalyst or some other kind of technology clubbed with this bioremediation. We are working on that as well.
Okay, good. And also you are mentioning about some of the wastewater treatment plant sludge in Nagpur.
Yes.
So there, what was your experience? From which treatment you are getting most of this POP? In the sludge.
Yes. In the activated sludge as well, if we will for the extraction of these compounds, we have two different methods like liquid extraction, solid liquid extraction. If we want to extract these compounds in the wastewater, so we'll have to separate the sludge particles from the water sample, first we'll have to identify the concentration or assess the concentration in the water. Then we'll have to process the sludge differently, and we'll have to club both the concentration to assess the actual quantity of these compounds in the wastewater. First of all, this thing is there. And as I observed in my studies or in my research work, is that like almost, as I mentioned earlier, like 90% of this particular compounds are being deposited into the sludge, dewatered sludge, after all the treatment process, because these compounds are not water soluble. They are like lipophilic in nature, so they just have affinity to stick with that particular particulate matter of or the particle of sludge. So they just get deposited as a sludge particle, not in the water. So a very less amount you can get into the effluent instead of this sludge. So sludge is the main source in the water bodies.
Okay. Thank you very much.
Yeah.
Hello, ma'am.
Yeah.
Your presentation is very nice. Hello,
Thanks.
ma'am, audible?
Yeah, you are audible. Yeah, please go ahead.
Ma'am, my question is that it is differ in the economical aspects and then other aspects from other chemical methods, bioremedial methods and chemical methods are differ in the economical aspects? Are both the
Yes, they differ in economical aspects as well, because if we are working on advanced oxidation process, such as like for example, advanced oxidation process, we are working for the treatment of water, right? So for that we'll have to make a particular assembly. We'll have to take some electrodes or anything like which is being used in that particular treatment. We'll have to select some kind of a specific substance for that. Electricity consumption will be there. So it is not economically viable if we are talking about the treatment of a huge quantity of wastewater or municipal sewage. But biological approach is the approach which we can inculcate with that particular activated sludge itself, because bacteria or microbes are naturally occurring. We'll just have to stimulate them for the degradation of a particular compound. They are degrading, they have the ability to degrade those compound itself, but in lab or in in this kind of research, we'll have to stimulate their that quality or gene or enzymes for the degradation of these kind of substance, so that they can accumulate or acclimatize to degrade such kind of compound, even their concentration is very much less into the environment. So in this way we can compare these two things.
Asmita ma'am, please unmute yourself.
hello, may I
Yeah.
audible?
Yes, now you are.
Available bioremediation methods. Actually, madam, my basic is chemistry. That's why I'm very much interested in this particular field. Thank you so much for your presentation.
So thank you so much for your this thing wishes. But here, like as a chemist and as a biologist, we can work together for development of new kind of strategies for the remediation of persistent organic pollutants or any other kind of substances, because solely bioremediation cannot be a solution, and solely chemical technologies cannot be a solution. Because for the degradation, if we will see the structure of these compounds, so we can see the structure of this kind of compound is very much complex. So to just degrade or just remove halogen atom, we can use some kind of chemicals treatment or any other physical treatment, and then for the ring opening and other things we can use the biological pathways. So in this way we can work together, the chemist and physicist and biologist.
थैंक यू सो मच. हम साथ में अच्छे से काम, और मैं आपसे बात करूंगी बाद में देवांशी मैडम से नंबर लेकर. थैंक यू सो मच.
Thank you.
Participants, we request you to switch on your cameras so that we can have group photographs for your attendance. And I personally thank you, ma'am. I'm really grateful that you accepted our request and you enlightened us today by your presence. You're so energetic. We really feel like delving into the POPs area and really hope to get in touch with you with some work in the future. Thank you so much, ma'am.
Thank you so much for this opportunity to speak on this particular topic, because it is very much important to discuss this topic with the persons or the students, because we are surrounded by the hell lot of chemicals, so we'll have to take care about them. So definitely, thank you so much.
Thank you, ma'am. Have a good day.
Thank you. So should I leave this meeting?
Yes, ma'am. Thank you so much.
Thank you.
Participants, please switch on your cameras if possible.